so strong.
Hey SMARS fans, how you doing? Hope you've had a good weekend so far. So, why should you use Jupyter Labs? What is Jupyter Labs? Why is it awesome? Let's find out together. So my name is Kevin. Come with me as we learn how to build robots, bring them to life with code, and have a whole load of fun along the way. So let me get right over to it. So let me get over to Keynote and we can have a look at what this is all about. So let me just check. Sound levels sound good. Yes, that's all good. Not too loud, am I? Right, so what we're going to be looking at today is understanding what Jupyter Labs is. You may not have heard of it before. I only came across it about 6 months ago, and it's undergone quite a bit of development since then. We'll have a look about how to install it. You can actually try it without even installing anything. There's a website we can have a look at as too. And we can have a look at some of the things that make up Jupyter Labs, something called Markdown you may or may not have heard before. And we can run some code as well on one of our robots. So I've got a host of robots here. We're going to be looking at this one today, which is our quad. It's got a little Raspberry Pi in it there, and that's running Python, and it will be running Jupyter Labs very shortly. And I've just got some other ones just there too. So let's get back to our Keynote. Okay. So, do you struggle with programming? Is this something, this is something I've heard quite a few times from various different people. Hey B Academy, how you doing? And there are different levels that you can, enter programming. So this one today is, I would say, kind of an intermediate stage. There's some things that we have to do which are not for beginners, and it's something that you can use, to experiment with. So for hobbyists, do you get yourself stuck writing code? Do you end up like getting stuck in a tiny bit of code and you think, why is this thing not working? Jupyter Labs will help us with that kind of stuff. Do you want to try things out without having to run the entire program each time just to get the bit that isn't working? And do you want to find do you find code editors complex and confusing? So some people will find all the bells and whistles and all the linting and stuff like that goes on quite confusing. At first, it will help you later on as you become more proficient. And also for educators, do you teach students how to code and you want to be able to develop some practical lessons that you can reuse very easily? Jupyter Labs is definitely aimed at that market too. So let's get over to the next slide. So what is Jupyter Labs? So it is a software environment for programmers. You can use it to develop code, just like the Arduino IDE or the Python idle or VS Code. But it isn't just for Python. Jupyter Labs can run many languages too. It allows you to run code in what they call cells. We'll have a look at what those are shortly. And you can document the cells as well. So you can actually separate the documentation from the cells and have it much richer than just like a / comment or a hashtag comment like you do with Python. I really do need to get this chair a bit, it's very squeaky. So how do we install Jupyter Labs? So 4 easy steps. So the first one, we just need to open up a terminal on Windows or on command line on Windows, isn't it? Or on Linux or the Mac OS. Just a terminal. We type Python 3 space -m and then vn, and what that will do is create us a new virtual environment. This is what I mean about it being a bit of an intermediate stage level. We then need to activate that environment by doing source vn/bin/activate. And then we can then install Jupyter Labs by using pip, which is our package installation manager. So we just do pip install Jupyter Lab and then pip install SMARS_library. And that's what we're going to be using today to control this bad boy here. So once we've done that, and they don't take very long to do, we can then run Jupyter Labs just by typing Jupyter-lab. So we shall have a look at that very shortly. If you don't want to install that, you just want to give it a go just to see what it's like, you can actually go over to try.jupyter.org, and that will enable you to just try out on one of their live servers. It's a little bit limited, you can't save your own work as I understand it, but you can try out the concept of it. So once you've got that loaded, and we will have a look at it in a second, there's only a couple of areas of the screen. There's kind of a files and folders area on the left hand side where we can create new files. There's a toolbar area where we can stop and start the cells. There is the editor itself, and at the bottom there's kind of a status bar thing too. Quite straightforward to understand. And then these cells that we talked about, that they have 3 different types. So there is raw, and we'll have a look at what that is in a second. There is code, and there is markdown. So raw, we don't really need to worry about this. This is for people who are developing slides and presentation materials from one of these notebooks. So I've said there, this is the definition that they give on the Jupyter.org website. A raw cell is defined as content that should be included unmodified in NB convert output. So what the hell is NB convert output? It's to do with how you convert some of this notebooks. So NB is notebook, how you convert a notebook into like a slide that you can use in something like Keynote or PowerPoint. For example, the cell could include raw LaTeX for NB convert to PDF via the LaTeX, or restructured text for using Sphinx documentation. If you don't understand what any of that means, don't worry. It is quite complicated stuff, that. So LaTeX is a formatting language that's used if you're in university and you're creating some scientific paper. You may use LaTeX to create a book. So you can specify, the formulas with all the different symbols and things. Mathematically, you can use LaTeX to do that. It will also do things like page layout as well. And PDF is a different variant. PostScript is what PDF runs on, which is an Adobe invention. So LaTeX is very similar to PostScript. And that's the language that actually gets sent to your printer when you print things too. And Sphinx is another documentation technology. So you can put Sphinx things within your code, and if you run Sphinx, it will then extract them and then make some really sweet documentation for you. And then the last statement it makes there is the notebook authoring environment does not render raw cells. So what that means is it just ignores them, and we can ignore them too. It doesn't really matter to us too much, but I wanted to cover off what that was all about. So Markdown. Markdown is awesome. If you've not come across Markdown, make a note to have a look at it right after this, because it is really, really cool. So what Markdown is if you're writing some code and you want to use the same editor to write really rich documentation, you can actually write it just by using some conventions. So we can have a look at all this in a minute, because it is just really cool. So my entire website, smarsfan.com, is written in Markdown, and then I run it through Jekyll, which will convert that into pure HTML, and then I use some CSS to make it look really pretty, to sort of add colours and things and formatting. But the actual raw Markdown files are really simple. So if I want to write a blog entry or update a page, it can take me seconds to do. And there's very little to get in the way. So I don't have to worry about the formatting of it. I can just type, hash and then a title, and I know that it'll get the full heading 1 style in HTML. And things like ** bold, * will embolden the text. And what it does is it doesn't get in the way of your plain text, but it can really enrich it. So this has been taken on by all kinds of organizations. So GitHub use Markdown for all their documentation. They use the same thing that I use to, in fact, that's how I host my website, through GitHub. So I can edit some files, save it, upload it in Git. Git will then put it to GitHub, and then GitHub will go, right, I recognize this as being a Jekyll's structure. So then it converts all these files into proper HTML. So very, very simple to manage and use, and we'll have a look at this, but this is something you really want to look at. And there's extended versions of Markdown too, so you can do things like tables within your text. You can do fancy fenced code blocks. We will definitely have a look at that. That's something that Microsoft have really extended in VS Code. So there's a thing, I think it's called Mermaid, where you can actually do documentation like diagrams, flowcharts, just using code in these fenced code blocks. Very, very cool stuff. So it doesn't get in the way of making really nice looking documentation, and the source of that as well is very simple as well. So we will be using that in our cells to make the documentation really, really enhanced. So we'll be definitely doing that in a second. And then the code is just code. So whatever we'd normally type in, like the Arduino IDE or the Python interface, VS Code, that's what would normally be in a code block. And code blocks are intended to be single steps. So you can see there I've got 2 steps. On the screen we have, this is 1 step, and this is the same step. There's 2 print statements, and then there's a little a=1 assignment there to a variable. That's all considered to be 1 step because it's in 1 cell, and then underneath that there is a second cell, and we can have a look at why that's actually a useful thing, and it's to do with how we execute the code 1 step at a time, which is a lot easier to when you experimented, to think in that way. And how do we run them? We can either press Shift and Enter when we've typed something in a cell, or we can click that little triangle there, which is on the toolbar, which is like a little play button. And the reason this is cool for educators is you could write a program with some documentation in between that would take your students through some kind of learning objective. and you can give it to them without any output in there. So they have to guess what the output is before they press run on that particular cell, and then they can see whether they were correct or not. So it's really good for learning, and it's good as well for us for experimenting without having to run the entire thing. Other cool things it does, so these are the reasons you should use Jupyter. It works the way that you do when you're experimenting. So you tend to think about one problem at a time and you'll focus in on that. And that's what you can do with these cells. It's completely free. So another cool reason to have it, why not? It's completely free. It includes the output of the code in line. So you type a statement, as we will do in a minute, and the output of that statement can be seen right underneath it. In fact, Apple have used something very similar to this in their Swift playgrounds. So this is definitely a way of developing code that more than one organization is thinking about. You can also include graphical elements in line. So if you use something called matplotlib, which is what a lot of Python data science people will look at, you can include that in line in Jupyter Notebook. So you can get this really nice looking graph output in line with your code. So you don't have to do it to a separate window. It's inside the notepad, inside the notebook. As I've said, it's widely adopted. So Microsoft have built this into VS Code. You don't have to install any extra components. It's there right out the gate. And it does help with your documentation. If you're creating something and you want to make this a richer experience for yourself later on when you come back to it, that Markdown can really make a big difference. Currently, I have to separate my Markdown as like a readme.md rather than having it built into the code. So that's something that definitely can improve things. So if you find these videos useful, please do me the honour of sort of liking, subscribing and clicking the little bell. I watched a really interesting video the other day about why a lot of YouTubers get burnout, and it's because without clicking that little bell thing, getting the all notifications, you might not realise that new video content is actually available, and certainly you won't do if you've not subscribed, because YouTube wants to make sure that people can see all different types of content, so they're not going to make you come back to one that you've seen before unless you click that little button. So it's quite important to you if you get value out of this to do that. What else have we? So there is also check out smarsfan.com if you've not been to there. That's all the information that I've currently collected to do with SMARS robots, the quad robots, the wheeled robots, everything to do with robots. You can buy components on there if you don't know where to buy the components from. And there's all the videos and the links and the tutorials. So lots of great content on there. And if you don't already know, we do a live video every Sunday. See, it's just me, me and my robots. That's the we. And depending where you are in the world. So guys in the chat, whereabouts in the world are you from? So Tom, Willie and B Academy, tell me where you're from in the world and I'll give you a shout out too. And yeah, so there's a couple of time zones there. So we've got the Americas and Canada on the left-hand side, sort of European, Pakistan, India, Russia in the middle. And then on the right-hand column, we have China, Australia, and I think still Russia as well. So yes, hopefully everybody understands where they can be if they can watch these things. And if not, you can always watch it on replay on YouTube later on. Cool. So I think it's nearly time to get to demo. It's demo time, my favourite time. Cool. So Tom's from Germany. Wiedersehen. Is that right? Is that goodbye? It is, isn't it? What's hello in German? I'm crap. I don't know any other language other than English and programming languages. I speak Bachi. That's about it. Maybe a bit of Klingon. Okay, so let's get over to, let me press the right button first of all. Right, so the way I'm going to do this is I'm going to load up, we'll do some Markdown first, and then we'll look at some how to install and use Jupyter. So what I've got is I've got this camera here. We have the overhead camera just here so we can see this robot and we can see how it's interacting with the code. And I have in front of me VS Code. So that's what I'm using to do the code. Oh, hello. So it's very straightforward then, isn't it? I know German's a very functional language, very straightforward. English is a whole mishmash of lots of different languages over the, is it Latin and Greek and Nordic languages, and Gaelic languages all rolled in. So it's just horrible. I can't imagine how difficult it must be to learn English, but there we go. Okay, so let's do some Markdown. So this is what's cool about VS Code and their their use of Markdown. So we have these buttons here. This one with it's kind of a split preview with a little magnifying glass there. If we click that, what that's going to do, it's going to render anything we do in the Markdown on the right hand side, and this is how it would appear when somebody else renders it too. So the first thing that we learn how to do is we do the hash. So let me just put in front of that the hash. So what that's done is that's made that heading 1 style. So if you know anything about HTML and web pages, heading 1 is a style that we use for giving headings at the level of 1. So we've got some Markdown there. We might have a heading 2 by doing 2 of them. So this is heading 2. And we can have a 3rd level as well, level 3, and so on. There's quite a few different levels. Now we can also do things like 3 dashes will give us the horizontal rule. If we want to do, let's have a think what would be great next. So some styles like bold. Let's just do one first of all. I think this is italic. So if I do that, so if you do 2 stars either side of a word, that makes it italic. If you do, 1 star, 2 stars is bold, like so, and 3 stars is bold and italic.
3-star club is called 3-star club.
Is that so? My home automation thing, whose name I won't mention. So what's going on there? I need to do 3. There we go. So that's bold and italic. If I separate these by lines as well, it will actually put them on separate lines too. And what else can we do? We can do a block. So if I do a little arrow, I can then say this is a call out, is it? Something like that. Then we can do the little back tilde. It's not a speech marks or whatever you call it. It's the back tilde, I think it's called. This is some code. So if we have this as, let's have a Python thing where we say define hello world, like so. And then we put a little tilde at the end of that block. Now currently it doesn't know that that's Python, and this is where it gets really cool. So if we do 3 of those, it knows that's a code block. It's now indented it as a block of code. And if we type the word Python after that first bit there, it's then coloured it in because it recognises this as Python. Now this isn't the interpreter doing this. This is standard Markdown. Lots of interpreters will do the same thing. So if I do that same kind of 3 things, the word Python and then some code, just in my regular text file that I upload to GitHub, GitHub will do the same thing when it renders it using Jekyll. So what else have we got? We have things like, so if we want to put in a website, let's just type in like, I don't know, apple.com. We can see there we've got this link that's clickable, but the convention is that you put them inside little brackets like this. So again, it hides them in the output, but then it knows that this is a sort of clickable link. Now that's great if you want people to see the link. If you don't want people to see the link, you have to use the square and round brackets together. So we could just say this is a hello Apple, and then in there we could do the apple.com, and we get the link there, but with the actual words that we put in the square brackets. Now, if we wanted to do an image within our document, we can do that too, and we use an exclamation mark and the square and the round brackets. So again, we could have, I don't know, image of something, and what would be an image? Let's see if I can guess one on smarsfan.com. So we have an assets images folder, SMARS logo.png, .jpeg maybe logo, maybe SMARS underscore logo dash white, something like that. I can't remember the name of any of these. Fave icon, how about that? And it's .ico, isn't it? And it's not under there, it's just under the root. We'll get there. I just wanted to display something, anything. Okay, you get the gist there. I'll find an image in a second. I think I have actually got some Markdown saved. So let me just have a quick look. Did I actually save one with... Nope, I don't think I did. Okay, not to worry. So what else can we do? We can do tables. I'll not do that here. We can do lists. So let's have a look at lists. This is quite useful actually. So if you do star and then an item, and then star and then an item, and then star and then an item, you can see there you've got a nice bulleted list. This is where it gets really cool. So say you want a numbered list, you just do one dot and then the item, one dot and then the item, one dot and then the item. But look on the right hand side, it's gone 1, 2, 3. So this is quite cool because it means we don't have to worry about where we're up to with the numbering, and if we change it round, we don't have to then go back and renumber everything in our list. We can just rely on it correctly numbering the item like so. We can do things like I said on the Keynote. So if I just go back to that for a second, I just jump back to the things that we can do. So we looked at lists, unordered lists, we've looked at code, we've looked at links and images, we looked at the headings and block quotes, and then the more advanced things, the tables, the fence code we have looked at. Footnotes are quite good. What else? Definition, strike through. Task lists are quite good. We can do one of those. So not sure if these render properly on VS Code yet. I don't think they've added this in yet. So we do another list and then we do a dash, but we have an open thing and then we have the item like so. Yeah, I don't think it actually renders them correctly yet, but that's how we would do it. If I do that on GitHub, that will actually work correctly because I've actually used that. And what happens is you get a checkbox or a tick checkbox or a clear checkbox. So, oops, let me just jump back to that one there. That's better. Okay, so that's the Markdown. Let's have a look at how we get Jupyter Labs up and running. So what I'm going to actually do on this one, I'm going to connect to my little friend who's just sat here, and I'm going to do that using the terminal. So I've got a terminal window here. Because it's got Wi-Fi, it's got a little Wi-Fi chip just there. I can connect to this over the Wi-Fi. So if I just log in there, we get my nice little SMARS modular robotic system welcome screen, and we can now go into SMARS Lab. So SMARS Lab. Let me just type that. Let's just have a look and see what we've got on here. So it is SMARS Lab. There we go. Okay, so what the first thing we need to do was create that virtual environment. I actually already have one here because I've been doing this this afternoon. So I just need to do the second step, which was to do the source, which we just need to activate by going to source bin and activate. Don't know why it's that. That's what you have to type. And you get this nice little VNV in brackets there that tells you you're now in the right environment. So I know that we're in, if I type Python version, it'll be at least version 3, not version 2, which is by default. Okay, so what we can now do is we can run Jupyter Labs. So if I just type Jupyter, and it's Jupyter with a Y dash lab, it's now going to run Jupyter Labs now. Because it's running on a Raspberry Pi Zero, it is a little bit slow to start up, but it will work. So we just have to wait 1 or 2 seconds while it does that, and then we can open up a browser and we can start cutting some code. So this is really cool because we can cut code and we can make this thing interact with Jupyter Labs. So let's just wait for that to fire up. So it's going to run its own little web server and all the code that makes Jupyter notebooks work. So when they first brought Jupyter out, it was just a notebook. So it was just like a singular file. And then they decided, well, people will probably edit more than one file. So what we'll actually do is we'll make it so you can edit multiple files. And that's where Jupyter Lab came from. So there we go. It's just firing it up now. In a second, it's going to give me a link. So there we go. That's the link. Ah, damn it. I didn't do the --IP, which I need to do to make it so that I can connect to it from a non-local machine. Hopefully it'll be a bit quicker this time to start up though. So what I mean by that is when it starts Jupyter Labs up, it will, for security reasons, just lock it down to your local host, which is that number there, 127.0.0.1. It's on port 8888, and it's in the folder called lab. And that token thing, again, is a way of locking down so that if anybody was on the local area network and they stumbled across this, they can't get in without that token. So it's just a secure way of locking this down. And the --IP equals and giving it an IP address, that means I can access it from this laptop that I'm using. So I could show you if that other camera was back on, but I think the battery's gone to sleep on it. I've got a spare one there. That's the GoPro that's been added to my array of cameras. Right, okay, so now we can open this up. So let me just copy that. I'm now going to open up a web browser and just paste that in there. And now we'll get to the Jupyter Labs interface. So let me just clear that out there. That's just me downloading all the awesome music for background. We can put a little bit on actually. Let's put on. Let's put this one on. Let me just quiet it down. How's that? Is that not too loud? Leave that in the background. Okay, right. So SMARS Lab, Jupyter Lab is loading up. It is a little bit slow to begin with, but it's fine once it's woke up. Okay, so we're nearly there. Promise, it's worth it. So it's just loading up all the libraries and everything into its very short amount of memory. Come on. I'll edit this particular section out of the replay, I think. Come on, right, so let's do clear workspace then. That's fine. Okay, let's turn that down a little bit more. Oh, here we go. Okay, so the first thing I'd like to do is just turn this mode into simple, and what it will do is just get rid of all that extra stuff, clutter around the screen. It makes it a lot easier for us to see what we're doing. So what I've done is I've created a file here that I call SMARS Experiments, and you can download this if you download SMARS Lab. It's in the Jupyter folder. If you've already downloaded SMARS Lab in the past, you can do a git update, git pull I think it is, to pull that in. I'll show you how to do that in a second. And let me just clear any of these outputs. So clear all outputs, there we go. Right, so what we're going to do is we're going to run one of these one line at a time. So I've got an entry here that says from SMARS library.SMARS library import SMARS robot. So SMARS robot is a class that I've written in Python, which enables all kinds of functions and functionality for this robot that we've got here. So let's do that. Let's just run one cell. So if we go to that cell there, we just press Shift and Enter. We can now see it's going to run that piece of code, and now that we've got a number there, that means it's executed, it's successful. We've not had any error messages, it's all good. Now we'll actually see that it's doing something on this next one. So I'm going to say robot equals SMARS robot. So the SMARS robot class has got all these functions that we can use, and I've created a variable called robot. So if I run that, it gives us an output. It says initializing robot. Now let's give this robot a name. I'm going to call this Quaddy. So I'm going to say robot.name equals Quaddy. And it says Quaddy is online. So I'm not going to run this next one. What I'm going to do next instead, I'm just going to create a new cell just by clicking this plus button, and we can have a look and see what we can do with this. So you can see here it says code, Markdown or raw. We could create some Markdown if we wanted to, like we did before. So we do the hash for our heading, and then we can say look at what SMARS can do. So what we will do there is we can use our little code thing that says let's do dir brackets robot. So we're going to have a look at what robot can do. So that's, if I now do Shift and Enter, we've now got look at what SMARS can do in a nice big title, and we have dir robot in a little code block. So let's actually create a new cell and let's do dir robot. Robot. Okay, Shift and Enter again. Now watch what happens when it executes this particular cell. It's just thinking about it. Come on. Let's try that again. It's taking a very long time for it to run that. It should be able to list all the different functions that that particular class can do. There we go. So all these different things, underscore means it's normally hidden, so we wouldn't be able to use that. But look at this, we've got backwards, clap, debug, default, forward, get telemetry, help, invert feet, blah, blah, blah. So let's create a new one. There was one there that was called help. So I'm going to say robot.help. And let's just run that. So this robot accepts the following commands: forward, and then in brackets, steps, backwards, steps, turn left, turn right, clap and wiggle, we'll have to try them out, get telemetry, wonder what that's for, stand, sit, swing, body, default. So we're going to run stand next. So watch the robot on the camera just here. These legs are going to do something when I run this. So I'm going to do shift and enter, and look, it's now stood up. If I do sit, let's see what happens now. It's now sat down. Let's do default and see what happens there. So the legs have gone into the default position. Let's do a wiggle. Let's see what happens with that. Let's try that again. Let's try clap. Let's try clap again. It doesn't seem to do very much there. I think it's too quick. There might be a bug there, actually. There's something called swing. Let's have a look what swing is. So let's go back to that default position. So I'm just clicking in the cell and doing shift and enter. So the legs are kind of at the body position. They're all in like that. And then let's do swing. And watch what will happen. You'll see each leg lift up and move to a 45-degree angle and then go back down again. There we go. So it's kind of like an X position. So that's quite a good position if you're going to start doing something like turning left or right and so on. So let's find turn left there. I'm going to go turn left. Let's do that again. This cord is slightly pulling on the robot, so let me just move that there so that it isn't pulling on it at all. Right, let's try that again. So turn left, turn left. Let's just do a few turn lefts. Let's copy that. Let's make it do it 4 times. Right. He's getting a bit caught there. Let's move it there and try turning right 4 times. So let's do that. I can hear some of them servos are pulling a little bit. Okay. So you can see he's definitely turning. This surface isn't great for traction because it's just a piece of plastic on a wood surface. Maybe I need some little rubber feet on him or something like that. So you can see there, we can get it to do things. We can get it to sit down, we can get it to stand up, we can get it to, we've not tried walk forward yet, so let's find that. So forward 1. So currently I've got a bug in this software, and it's to do with walking forwards and walking backwards. And this piece of software has actually, Jupyter Labs has actually helped me investigate where this problem is, because I could try all the other commands out without any of the complexity of having to do things on the command line or write special program. I can just dive right into Jupyter Labs and I can just try out the classes that I've already written. So I can see there by doing things like the leg reset position or doing the swing position. I know that them work, so the code that's got the bug must be in the walk forward block of code. So these are some of the cool things we can do there. There was something that we saw before about get telemetry. So let's create a new code block and do robot.get telemetry. And we can see what happens here. So look at that. It says left leg front 40.5, excuse me, right leg front 135 degrees. So let's try something out. Let's make the legs go to the reset position. And then now let's try get telemetry. You can see they're now different angles. So in my SMARS lab software, I can use some JavaScript in the background to go and run that get telemetry, because it's actually an API and that's in the JSON format. So it can pull that back and it can enable me to present that updated on the screen within SMARS lab. So that's what get telemetry is for. So I can understand what all the angles are for these different servos. So how cool is this? This is pretty sweet, isn't it? So let's see if we have any other files that I've written in here that we can pull up. I think there was one or two. So I've got one there about Markdown. Oh, that was just one. I was trying out some Markdown. So in here again, we create, let's go back to our experiment. And what we can do there is we can create a new little area here, and we could call this investigating an experiment. Oops, and what we need to do is make that a Markdown, otherwise it will throw a code, it will throw an error. And if we might want to do something else, like put that little indent block there, so we can see that it's indented. So it can really help us put together you know, a structure. So if you were preparing a class, if you was an educator and you wanted to sort of, you know, take your students through some very straightforward things like maybe making a robot walk forward or standing up and sitting down as just the first thing, you could have that as a cell, and above that could be some Markdown that's got a description of what you're going to be doing in that particular experiment. And within the code, if we use the print statement, that will actually output. So let's try that. So if we just have arbitrarily, we're just going to get a variable. We're going to call it, say, I don't know, motor speed. Speed equals 10. We run it. Doesn't appear to do anything. If we say motor speed now as the next line, it will output what the value of motor speed is. So we don't even have to do a print statement. We can just investigate it by typing in what the name of the variable is. So that could be really useful, again, if you're trying to experiment and you want to understand what's going on. So if we was to create here, and this is, again, the great thing, we can just overwrite that cell that we've just written and rerun it. And everything that came before it will still be as it was at the time up to that point. So if we create a little function here and we call it speed, is that what we want to have? Yes, so we'll call it speed, and it's going to take two variables. I'm going to type time and distance. And what speed is going to do is it's simply going to return time distance divided by 60. So let's put that in some little brackets too, just so it knows what it's doing. Okay, we can run that. And now we can create another line further down. Let me just move that one up. And we can use that speed, so we can say, so it's going to be half an hour, 30 minutes, and I'm just thinking, should I actually print something out there as well as returning it? Yeah, instead of return, I'm going to change that to be print. Print, and let's say speed s equals time of distance, and then we can do print s. And if we do it like this, if we use the f in front of a string, we can do some fancy things like include the variable name within some curly braces. I did say this is intermediate, so bear with me. So if we say speed is, and then the speed in miles per hour. Oops, I'm just going to do shift and enter to run that. Now on this next one, I'm going to say 30 minutes, and the distance we've travelled is, let's say, 2 miles. Run that. Speed is 1 miles per hour. So let's do that. Speed is, so I just do shift and enter there, shift and enter again. Speed is 1 miles per hour. So if I was to travel 4 miles in half an hour, we're doing 2 miles an hour. If I do that, 4 miles in 60, we're doing 4 miles an hour. So that's working as a little function there, just as an idea of the kind of thing that we can include within a particular cell, and we can interactively then see what's going on within that. So I think that's quite useful in this sort of education environment. Or if you're in the debug environment, if you're just trying to figure out why on earth your code's not working, you can drop it into a Jupyter notebook, and I find it's a bit more interactive. You can run little bits at a time and see why something is or is not working. So I was trying this to figure out why there's a bug in this walking pattern. We actually did an entire video on the walking cycle, so I think all I need to do is just rewatch that. So I was looking at that a while back, so there is an entire video. I'll do a link in the little card above when I remember. So that's at 7:45, and yes, we've already done a video on that. So we can have a look at that. So what else did we want to look at on here? So we've looked at Markdown, we've looked at how we can run code, and we've got our little robot doing little dances and things. We did wiggle and clap, which was quite cool. Let's just do another one of them. So let's just reset the legs. Oops. Let's do the swing position like that. And let's make the robot do a bit of a wiggle. I like that one because from above that looks quite dramatic. So he's sort of sitting down, wiggling his back legs and then standing back up again. Cool. So I hope you find that a useful overview of what you can do in Jupyter Labs. I think it's a really cool piece of software. It's definitely being developed quite intensively at the moment, so it will increase in its feature set as well. So but what I mentioned before is if you go to try.jupyter, if I can type correctly, jupyterlab.org, I think it is. I can type properly. There we go. So what this is going to do now is it's going, that's not the right one. Let me just, Jupyter, is it just Jupyter? What did I type in? try.jupyter.org. There we go. So try Jupyter. So you can either do the classic notebook, Jupyter Labs, or Julia, which is a particular language. There's all the other languages as well. So you've got things like C++, Ruby, but we were looking at Jupyter Labs. If I click on that tile there, it will then load up inside this browser without us having to run anything locally, an instance of Jupyter Labs. So they've probably got a bank of Raspberry Pi spinning these things up somewhere. There we go. So you get the same idea again. And they've written their documentation that you can see here. If I just double click in that, Markdown. So how cool is that? And then they've done some, look at that. They said we're going to explore the, oh look at that, they've got some fancy stuff going on there. That looks very nice. So you can do matplotlib inline. Let's just run this and see what happens. Have I not? I think I need to run these one step at a time. There we go. So you can now adjust these sliders and see what happens interactively within the notebook. Mind blowing. Let's try that. Just going to keep running these ones until they've got something of interest. Here we go. So matplotlib is going to plot a little histogram. There we go, and then it's going to plot a histogram with a title, so you can see they've added a title to that one. And so it's really, really cool. Nice thing to play around with. We can use it in robotics. It can help us develop better code and interactive with our robots too. So hope you like this this setup. So let me just have a look at the slides. I think we actually came to the end of them. If I just go back to the slide deck. So yes, we looked at all that. We did that comment of the week, yes. So, comment of the week. So we've had quite a few comments this week. So BE Tutorial said, how to make 3D printer using a Raspberry Pi. So I have a Raspberry Pi. If I go over to that view there, I've got one very similar to this here. This is a Raspberry Pi 4. I think I've actually got a 3. That's just the camera cable that's dangling there. But I've got one of them plugged into the front of my Ender Pro printer, which is, that's what this cable here is. So my Ender Pro printer is just sat here. And the Raspberry Pi, let's go back to that one there. The Raspberry Pi is running Octoprint. So if you use Octoprint, you can use that as a web interface for controlling your 3D printer. So that's what I use my Raspberry Pi for. So Tom says, nice video, and this is just the beginning. Absolutely, Tom. I was really blown away with the stuff that you've been doing with your SMARS, with the sort of edge detection so it doesn't fall off the edge of a table. And what else did you do on that? You were doing some pretty cool stuff with the ESP32s. I've got one or two of them knocking around, actually, that I'm intending to use too. It's got my little desk drawer next to me. Chip says, are you an educator? You have some sophisticated setup for your video presentations and put a lot of effort into making them. So absolutely, yes. I really enjoy making videos, and I do look silly with these on my hat. I do enjoy making videos. I built this summer house so that I could work from home a bit more effectively, but I've also got a space where I can build robots and just have all my man cave stuff about. And I've also set up this mini studio as well for putting videos together. So I really love making YouTube videos and creating content that people can watch. I get a lot of interactivity out of the audience as well, so I enjoy that. So yes, I do put a lot of effort into these. I appreciate that you've spotted that, but I'm not an educator. I'm just a very enthusiastic individual. And Fam says, you did a great project. I love SMARS, or I like SMARS Robot. So again, SMARS was invented by Kevin Thomas. That's not me. I know some people from different countries where their names are reversed. So I know in China sometimes the surname is actually in front of the first name, whereas in Western it tends to be first name comes first, your Christian name, or your first name comes first, and then you have middle or surname. So it can confuse people that I'm called Kevin as well, and Thomas, Kevin Thomas, who's the inventor of SMARS. Thomas is a Christian name. It's also a first name sometimes, so that might be a bit confusing that we're both called Kevin and there is this other name that's a Christian name. So I can understand why people get confused about that, but I'm not the inventor of that. I cannot take the credit for that. This design is purely of Kev Thomas's design and invention. He went through quite a few iterations of it before he struck on this one, but there's so many clever features of the SMARS robot. The fact that you can print it on a single printer, the fact that you know it's designed perfectly to fit a Arduino, and that the battery compartment can fit a 9-volt battery perfectly in there. Could do with a bit of an on-off switch, I think, and 9-volt batteries are great for starting with, but you probably want some 18650s or something. But then these tracks, that's quite genius. That really does take somebody who's got engineering mindset to come up with that. But yeah, that's the unique look of SMARS. Hey Uday, how you doing? Thanks for joining the stream. Glad to have you on board. So just been talking about Jupyter Labs today, and going through the comments of the week. So let me just get back to my slide deck and see what else we've got. So I've already talked about that. We've got a new video every Sunday, 7 p.m. Greenwich Mean Time. So next week we're going to be doing one for beginners. So if you've not looked at Tinkercad before, it's by the same people that do Fusion 360. It's by Autodesk, and they have some software which is purely web-based, so you don't need anything to install on your machine, called Tinkercad. And it's quite an unusual CAD package. So instead of doing like parametric modeling where you sort of specify things and everything's parameterized, you create a cube or some kind of basic shape, and then you add or do some operation on that shape with another shape, and you do it one step at a time. And because it's step by step, you can also use these blocks. So blocks have become quite popular with things like Scratch. I've done a video very, very early on about how to get Scratch and Python working with SMARS robots, so we can have a look at that. But Tinkercad also lets you build circuits. It's quite like fritzing if you've used that before. Nowhere near as complicated as something like Eagle, but you can grab an Arduino, you can plug in some motors, a battery and a sensor, and you can then run some code. So this is all one page here. You can run some code just by grabbing some of these blocks. So it's great for people who are starting out, who just want to try an experiment, but haven't quite got the tenacity and the specificity that you need to be a coder, because you make one spelling mistake or one character's uppercase when it shouldn't be, and all bets are off. Whereas just dragging blocks and adding the blocks together, you're still thinking in that programmatic way, but it's a much easier way to do for starters. I know a lot of kids, a lot of educators and schools will be using Blockly and Scratch and M-Code and Maker. They're all using the same kind of technology. So Google have invented this thing called Blockly, and a lot of these things are based on that. So Tinkercad uses that, and we'll be having a look at that next week. So we'll be doing some pretty cool things, trying to make a SMARS work with an Arduino with Tinkercad. So that's going to be some fun. Hope you'll join me for that one too. So let me get back to my slide deck. I think that is pretty much the last slide. Yes, that means we're done there. So back over to the chat. So how are you guys doing? So Uday, whereabouts are you from? You always seem to join the end of the stream. So I do a countdown timer at the beginning of the stream to try and count people in. And I do put the videos I'll do two things. I'll set up the stream in advance. So next week's stream, the one that I've just talked about there, the coding for beginners with Tinkercad, that is now a stream on my YouTube channel. So you can go on there, you can find it and do the reminder button. And you can also go onto the Facebook group, and I'll create the event on there so you can see that the event, so it should notify you. I think I am reliant on Facebook and YouTube sending those notifications out, but if you click the bell, you definitely get the notification via that. So so you're from Germany as well. Hello. So yes, Tom is from Germany as well, I believe. So I'll just see in the chat there. I'll put it on the screen so you can see. Yes, so there we go. So you're from Germany. Cool. Yeah, so I've had a look to see where people are based, and there are quite a lot of people all over the world. I'm always surprised about just, whereabouts people are actually coming from to watch this. And it's quite a spread of genders and ages as well. So it's not just all clumped together of one particular age group or gender. It is quite spread across, so that's pleasing to see as well. So yeah, Uday says, I do get the reminders, but yeah, something keeps coming up with kids at home. Lockdown, I understand this, Uday. It's quite difficult to, especially if you've got younger kids as well. So don't worry about it. You can always catch the rest of the video on the playback. If there's something in there you wanted to see. I know not every single video will be for everybody's particular taste. We're at different levels of development. I'm trying to understand who my audience is as well. Who watches this, so I can make better content for you guys. So let's take a quick poll then. Who's how would you see yourself? A beginner, an intermediate, or an advanced programmer? And what about from an engineering or electrical point of view as well? Beginning with, are you a beginner, an intermediate, or an expert? So I would say for myself, programming wise, I'm somewhere between intermediate and expert. From an engineering perspective, somewhere between beginner and intermediate, I would say. And then the electronics, probably beginner to intermediate as well with electronics. I'm not great at soldering stuff and understanding the theory behind it. I just know stuff works when you put them together, and I'll just Google something. So have a lot of components. There's a load of stuff in them things there, but from electronics point of view, I've not quite mastered that yet. So that's kind of an overlapping Venn diagram of three circles of engineering, coding, and electronics. And some people tend to have a strength in one or two areas and a weakness in another. So I'd be interested to know what you guys, where your strengths and weaknesses are as well. So if I understand that, I can make better content because it'll be more directed towards those particular needs. And if it's way above my level, if it's all expert stuff, it'll probably be a different channel. I'm not an expert in everything yet, but I will be soon enough. I'm here for the long run, so I will be putting these videos out for years to come. So yes, cool. So what I'll do now then, I know that there can be up to a minute delay on when I ask a question and when you get that through. So no matter how long you've been doing, that's how long I've been doing them. All right, everything intermediate, I'd say, yeah. And Tom says the same as Uday. Everything intermediate. That's interesting. Yes. So that means that I can. I'll still do the Tinkercad one next week, because there's some quite cool things in that I didn't know you could do in Tinkercad. It's good to look at different software as well. And sometimes I find if you have a problem, sometimes it's easier to sort of step back from all the complexity of something that you're building and just use a simpler tool to sort of figure it out, and then you can go back to what you're building. So sometimes I will drop out and use something like Blockly, figure something out, and then I can go back in, just because it's a different way of thinking about it. And I'm a visual learner, so I like to see things. Some people are more kinesthetic, they're like action oriented, they just try stuff out. They're the sort of engineering people, or they're the auditory, and people are like text and to hear things. So people have different learning styles. I try and cover off all bases by showing people a physical example of something being built, like the little robot that we did the quick video on midweek, and also tutorials with some visuals as well as some step-by-step stuff. So hopefully it touches all the bases there. Cool, so we're coming up to the hour now. I shall let you get back to what you're doing. You can have a look at the full thing if you've missed it. And if not, I shall see you next week. We'll be looking at Tinkercad for beginners. So thanks everybody for watching. I really enjoyed your company this week. I shall see you next time. Bye. Oops.